Hello. Excuse me. This is Stoichiometry 103, part 2. And the topic is using limiting reactant and excess reactant. And I want to specify on that. We're using limiting reactant to predict an amount of product. Okay, and the homework is still the Stoichiometry 3 worksheet. And I just wanted to point out something that on the worksheet to the left side, you'll see each question is labeled with a D1 or a D2. And that stands for day 1 and day 2, because normally when I teach this topic, I take 2 days to do it. The first day is learning to identify the LRER. So it's determining the limiting reactant, excess reactant identity. That's what the part 1 notes were. And then the second day is using the limiting reactant to predict an amount of product made. And that's the part 2 notes, which I'm about to start. So anyway, that's just keeping a big picture there. And so we'll break this and write a couple things to start with, and that is that the limiting reactant limits the amount of product that can be made. So once you identify who's the limiting reactant or the substance that is the limiting reactant, then you can do a stoichiometry calculation to predict the amount of product that could be made. So you always use the limiting reactant have moles to predict an amount of product. And the have moles are just your start number. Okay, so we're gonna do a calculation example here. And we're gonna do the combustion of aluminum for our reaction, Al2O3. And this is a 4, this is a 3, this is a 2. And I'm going to use also gases at STP in this example. So we have this reaction, and we're going to say a reaction occurs in which 30 grams of aluminum react with I'm gonna say 40 liters of O2, and that's at STP. Okay, and we have 2 questions. Which is the limiting reactant and the excess reactant? So that's our first question. And then the second question would be how many grams of Al2O3 could be made? So this question right here, which is the limiting reactant, excess reactant, this is like the D1 question, day 1. And then how many grams of Al2O3 could be made? This would be like a D2 question, day 2. That is a D, looks like a P. Okay, so our first job is in the day 1 question, or the first part, is to convert to moles. So we're gonna take the amounts that we're given, 30 grams of aluminum and 40 liters of O2 at STP, and we're going to convert those to moles. So we know the molar mass of aluminum, 26.982. And we're gonna get 1.11 moles of Al. And then we know that for every 22.4 liters of gas at STP, we have 1 mole. So 40 divided by 22.4, oops, delete. And we get 1.79, and that's moles of O2. And we're gonna go back to our day 1 tradition and mark this as what we have. And then we're gonna go over here and we're gonna do a need calculation. So we wanna know how much O2 do we need and how much Al do we need. So we're gonna go for Al here on the bottom because this is aluminum. We wanna get rid of aluminum and we wanna know how much oxygen is needed. So 3O2. So we're gonna have 1.11 times 3 divided by 4, and we get 0.8325 moles of O2 are needed. And then we're gonna flip this over and we'll do 3O2 to 4Al. 1.79 times 4 divided by 3, and we get 2.39 moles of aluminum are needed. Okay. So that's the day 1 calculation. We're going to compare what we have to what we need. I have 1.11, I need 2.39. So the moles of aluminum, what I have is less than what I need. So I'm going to identify these half moles of aluminum as my limiting reactant because I have less than I need. And then if I compare across here, I have 1.79 moles of O2 and I need 0.8325 moles of O2. So this is my excess reactant. Okay, now that's the first part of the question. In the second part of the question, I'm going to scoop this down here. So we've identified our limiting reactant as the aluminum. Okay, so Al is the limiting reactant. Therefore, we would bring these moles of aluminum down. So we bring down the half moles of aluminum. And stoichiometry our way to aluminum oxide grams. So this would be a moles to grams calculation. Okay, so we're gonna bring these 1.11 moles down of aluminum. And we know for every, where's our reaction? There it is. 4 aluminums. We have 2 Al2O3. So we're at moles and we want to go to grams of Al2O3. So we're going to finish with the molar mass of Al2O3, which is 101.961. And you would get that if you added 2 aluminums and 3 oxygens. So the math I'm going to do is multiply everything together on top. And then divide by 4, and I get 56.6 grams of Al2O3 could be made. Okay, so that's an example of where I've identified who's limiting and who's in excess, and then I used the limiting reactant moles. I brought them down here to start a moles to grams calculation because the limiting reactant limits how much product can be made. Once this is all gone, we should have 56.6 grams of Al2O3. And then a second question, or a kind of a probe question for this that I didn't include up here, would be how much excess reactant is left over. And all you have to do with that is take the excess reactant half moles and subtract the excess reactant need moles. So we'll go back up here, we'll identify that O2 is the excess reactant, and we'll have 1.79 moles of O2. And that's what we have, and what we needed was 0.8325 moles O2. Just do a quick subtraction there. 1.79 minus 0.8325, and we get 0.9575 moles of O2 left over. Okay. So that is an example of using the limiting reactant moles to find the amount of product that is possible, as well as predicting how much excess reactant would be left over. Okay, that is it for the notes for this week. And if you have any trouble, or you have questions, any kind of questions or comments, please feel free to send me an email, and I will be available to video chat on Friday in an office hours situation. And for you guys, that will be starting at 11 a.m. on Friday the 24th. So just if you want to video chat, just send me an email. I'll send you a Google Hangouts chat, and we can turn that into a video phone call or video hangout. Okay, I hope you're doing good, and come to office hours if you need. Okay, bye.